This video is brought to you by us, RealPars. Join the top 1% of PLC programmers. Learn from the world's best so you can join their rank. Head on over to realpars.com and start learning now. Electricity is produced by a diversity of energy sources and different types of technologies. We all have at some point heard about fossil fuels, nuclear energy, and renewable energy sources. According to the U.S. Energy Information Administration, in 2020, natural gas represented the largest source of energy production at about 40%. Coal represented about 19%, petroleum at 1%, and nuclear energy, producing electricity from nuclear fission, represented 20%. As for renewable energies, those have been rapidly varying their share of U.S. electricity. The total amount of electricity produced by renewable energy in the U.S. is about 20%. Here is a breakdown in 2020. Hydropower plants produce about 7.3%, wind generation 8.4%, biomass 1.4%, solar 2.3%, and geothermal 0.5%. Renewable energy has become a very hot topic in today's world. We see and hear more every day about solar and wind power generation. What we don't talk about, however, is that with the increased use of wind and solar energy comes the increased concern about grid stability. When you flicker your light switch at your home, what you're doing is essentially requesting the power grid for more power, or in other words, requesting what is referred to as more load. Since a good, efficient, and cost-effective way to store energy is not yet a reality, that energy needs to be generated instantly and transmitted so that you can then have light. The equilibrium between how much load is generated and how much load is required by the grid is a continuous balancing act, which needs stability and is crucial in order to avoid blackouts. The energy generated needs to constantly be equal to the energy consumed. When it comes to generating power via the use of wind or solar energy, there are uncertainties that need to be accounted for. Either the sun is bright and shining, or it is not. Either you have wind making your turbine spin, or you don't. What we are doing by the addition of those energy sources is essentially adding more and more instability to the grid. This is where hydropower comes in. Not only do the hydropower plants have the ability to store fuel, or water, they also have the ability to respond to grid variations, also referred to as load requests. Remember the light switch? Within fragments of a second due to its governing systems that control the turbine speed. That is why hydropower is often referred to as the guardian of the grid. Now we know why hydropower generation is so important, but how is hydropower actually generated? How does the energy from water end up powering the light in your house? Well, the energy is generated by the same principles ancient Greek farmers used to grind grain, the flowing water spinning a wheel or a turbine. Hydroelectric power plants are always located near a water source due to the fact that water is the source of hydroelectric power. Inside the power plants, there are different types of turbines. But for today, we will look into the turbine known as the Francis turbine, or the Friendly Francis. It takes the friendly nickname due to being less complex to control, with fewer parts and fewer variables. Let's get to it. If you have watched the previous RealPars video, Power Plant Explained, you might remember some of the parts shown here. And if you haven't, we highly recommend that you do so. You can find the link to this video in the description. Let's start by explaining the need for a dam. A dam raises the level of water and controls its flow. The difference in elevation created by the dam between water level from intake and discharge is what is referred to as head. With the exception of the not-so-common diversion turbine, which relies on the natural flow of water to create motion, hydro turbines are often built at a lower elevation. Francis turbines require a low and medium head. This means that the dam is smaller than when compared to the dams needed for the other turbine's head's requirements. Water flows through large pipes, which are called a penstock, inside the dam, and turns a large wheel called a turbine. High pressure flows through the penstock. Between the reservoir and the penstock, there is a gate called head gate or intake gate. When open, it allows water to flow from the reservoir to the turbine. Now that the water has finally reached the turbine, let's take a deeper look into what the Francis turbine actually looks like and how it spins. The water flows from the penstock into the scroll case or spiral casing, a spiral-shaped intake that guides the flow of water from the penstock to the very important wicket gates. Wicket gates are a series of gates surrounding the entire turbine runner. They can be controlled to go from fully closed, not allowing any water inside the turbine, until fully open, allowing full flow inside it. As the water gets into the runner, the turbine spins. The more water in, the faster the turbine spins. The way to open and close the wicket gates is through servo motor control. The shift ring has links attached to the wicket gates themselves and the center disc, so, as the servo motors move back and forth, the gates fully open and fully close. Wicket gates are how governors can control the speed of the turbine. The turbine then turns the attached shaft, which spins your generator, to produce electricity. That electricity then travels through power lines all the way to your home and gives you light. Other than the friendly Francis, we have two other types of turbines, the Kaplan and the Pelton turbine. A Kaplan turbine has not only gates but also blades. A Pelton turbine spins on air, just like the Greek farmer's wheels. And to finish off, here are some fun facts about hydropower plants. China's Three Gorges Dam is currently the largest hydroelectric power station in the world and the largest power-producing body ever built, at 22.5 gigawatts. To create the dam, such a large amount of water was moved and relocated that this shift of weight literally slows the rotation of the Earth. Itaipu Dam is located on the border of Brazil, Paraguay, and Argentina, and its installed generation capacity is 14 gigawatts. Although in the border of three dividing countries, the power plant supplies power to only Brazil and Paraguay. The Grand Coulee Dam in the state of Washington on the Columbia River was built to provide irrigation and to produce hydroelectric power. With a capacity of 6.809 gigawatts, Grand Coulee is the largest power station in the United States. Now that you have a good understanding of hydropower, let's summarize what we've discussed today. Although hydropower represents only about 7% of the energy sources in the USA, it is extremely important for grid stability. We learned how Francis turbines work. Water flows through the penstock inside the dam, turns the turbine, making the generator spin, converting the energy of flowing water to electricity. The other two types of turbines are Kaplan and Pelton. Three Gorges Dam in China is the largest dam in the world at 22.5 gigawatts. Did you know that you get a great discount on Siemens PLC starter kits when you get a RealPars Pro membership? After signing up, you will receive a promo code that can be used to order a professional Siemens PLC starter kit at a discount price. The PLC starter kit also includes lifetime access to the TIA Portal Basic, which is the PLC programming software to program Siemens S7 1200 PLCs. This means that you'll be able to have both the hardware and the software to learn and practice what you learn in your courses. Go to the RealPars Learning platform and get your Pro membership now. You can find the links in the video description as well.